So now that we have the list of basic functions, then we can play with them. So let's start with an example. So let's go ahead and let us graph the function f of x equals x squared. Let me say y. Actually, no. F. Let's graph the function f of x equals x squared. And let's take this picture and shift it up 2 units. I mean, the moment that you have a picture, all we need to do is grab it and shift it up 2 units. Okay, so we can do that. So let's see. I'm going to draw this on the same graph. Okay, just to make it obvious. And then, of course, the question that we're asking here is, what is the formula of the new function? Because when you do this, when you move the graph, that's it. You get a different function. It's no longer the same function. Okay. So it has a formula. So the question is, what should this formula be? Let's see. Should be able to do this without too much trouble. So let's see. X squared, the function x squared, we know what it is. This is one of our basic functions. So I'm going to draw some points. So 0, 0, 1, 1, and then let's do 2, 4. So 2, 3, 4. So we get this guy, this guy, and then we have the function here. Try to keep it more symmetric, otherwise it looks weird. Okay. All right, so this one is the function f of x. This is the function f of x equals x squared. And now what we want to do is we want to produce a new function out of this. There are many things you can do to this picture. In particular, I could take this picture and move it up 2 units. So what I mean by moving this picture up means that we are not changing the x values. We're not affecting the x numbers, but we are affecting the y numbers. For example, when x is equal to 1, this one has y equals 1. Now, when x is 1, I want it to have y equals 3. Because I'm moving everything up 2 units. You understand this? So it's a vertical movement. So that means the point 1, 1 is going to go up to 1, 3. So this guy goes up here. The point 0, 0 is going to go up to 0, 2. So this guy is going to go up here. And the point 2, 4, where does it go? Where does the point 2, 4 goes? 2, 6. So it's going to go up here. 2, 6. Okay, this guy goes up here. Do you understand this? And then similarly, the other side. Okay, so this guy goes here, and this one is going to go here. And then the thing is that every single point on this picture is going to undergo this transformation. It's going to be lifted up 2 units. So then we just have exactly the same shape, but 2 units above the previous one. So we still have our parabolic shape, but 2 units above. So this is 2, 6. Let's call this function g. This is the new function g. Do you understand this? Okay, so let's see. Thinking about this, notice that the x is not being affected. Okay, when you plug in, when you plug in 0, you can plug in 0, 1, 2, etc. And then what's happening is the function is moving up. So the y is what's being affected. So if we're going to change the formula, we need to change this formula, but we should not be touching the x because we're not affecting the inputs. What we're affecting are the outputs. Okay. So what do you think is a reasonable formula that we should use for the red one? In this case, what would be a reasonable formula? After all, it comes from the black one, right? From the x squared function. It's just that we're saying the y is always 2 units more because we are moving up 2 units, right? So what should be the formula for this? So x squared plus 2. In other words, g of x will be x squared plus 2. Is this clear to everybody? So this plus 2, what's the job of this plus 2? What is it doing? What is it doing? So it's shifting the function f up by 2 units, right? So what this does is it shifts f up by 2 units. If instead of plus 2 I would have done minus 3, what do you think that would do? It's going to make this graph go down 3 units because now the y values are going to be 3 less than what they used to be. Do you understand this? So this is our first information. If you want a picture to go up or down, what you do is you add or subtract a number. Okay? If you want it to go up, add a positive number. If you want to go down, subtract a positive number. Okay? So let's write that down. So vertical shifts. Okay, so vertical shifts. Let's see be a positive number. Then we say the following. So the function y equals f of x plus c is a vertical shift up. So a vertical shift of f up by c units. Okay, and then similarly, if you instead of adding, you subtract the number, then this is a vertical shift down, a vertical shift of f, which is down by c units. Okay, so once again, 2 things. You have to be able to, given this formula, to recognize that this is what you need to do. Okay, start with the x squared and move it up 2 units. Or if you see the red formula, in general, sometimes in general this is harder, but to recognize that this is just the transformation of this one up by 2 units. So that's a harder job, to take a picture and then produce a formula out of it. Okay, so what we're going to be doing is the other way around. You're going to be given the formula, so the function itself, and then you're going to graph it by recognizing certain transformations happening to it. Okay, so let's do some examples. Oh, let me destroy this a little bit more. In this case, if you see this function, what is the function that's governing the shape of this one? In other words, we call that the parent function. So what would be the parent function for this one? Yes? The x squared function. So when you see this, then you need to understand that this is the x squared function, and then we are moving this function around. In this case, it's the x squared function, move up 2 units. So how do you graph this? You start with your parent function, which is the x squared, and then you do the corresponding transformation. Okay? In general, you're going to have more than one transformation. You could have 2 or 3 transformations in the same formula. My advice to you is do one at a time. Recognize the parent function, and then you do one transformation at a time until you get to the final destination. Okay? That will be, it's a little bit longer, but it will be a safe way of arriving to the correct graph. Okay, so let's do examples. So examples, let's see, sketch, and then let's do f of x. And remember, every time that we draw a graph, if any intercept shows up, you need to find it. If there is an x-intercept, you need to find it. There is a y-intercept, you need to find it. Okay? Either by showing it to me on the picture or by, solving the corresponding equation and then mentioning that somewhere. So let's sketch square root of x minus 3, and then let's sketch absolute value of x plus 1. So let's see. Let me do the first one. So for number 1, so we have the function f of x equals square root of x minus 3. So the first thing that we need to do is recognize what's the parent function. By parent function, I mean one of the 8 basic functions that I just listed. Okay. So let's see. We have here square root of x minus 3. So what is the basic function for this one? Which one is it? Should be clear that it's a square root, right? Just by looking at this. So first one would be the function y equals square root of x. This is what we call the parent function. So let's first, I strongly encourage you to have to first lay down the plan. In other words, instead of just graphing, let's go ahead and let's write down the sequence of formulas that are required to be able to get to the given formula. Okay, in this case, it's just one extra step, but you may have to do this 4 or 5 times depending how many transformations you have in here. Okay, and there are rules to which transformation you should be doing first. Okay, in the case of vertical and horizontal shift, it doesn't matter which one you do first, but when there are reflections into the mix and so on, then it matters which one you do first. Okay, so I will tell you the order once we get there. Anyways, you have to think of this as a game. So you start with the parent function, and then you're only allowed to do one transformation at a time, and your job is to build your way up to this formula. Okay? Right now, the only rule of the game that we know is that we can add and subtract numbers to the whole function. That's the only rule that we have discussed. As we go along today, we're going to be introducing new rules to this game. Okay? So let's see. You are only allowed to add and subtract something. So what can you do to this formula to obtain this one? You subtract 3, right? So you do minus 3. So that would be the next step. One of the rules says I cannot add or subtract stuff. Okay, I'm gonna do minus 3. And that's my formula. So now once you do that, you did the minus 3. So that immediately tells you what's happening from 1 to 2. So what sort of transformation is taking place? So we're going down. How many units? Down 3 units. So once you have this written down, this is like a plan. You already have laid down your plan. Now, the only thing that you need to do is go to your memory, start by the basic graph, how does this guy look like, and then do the corresponding transformation. That's all you have. Okay? So now here, that's why you need to memorize those basic functions. Because now we are back to the parent function. You need to know how this looks. How does this guy looks like? Well, it has this sort of shape. Right? A square root, and remember, you should always have at least 2 or 3 points to move around. So I'm just going to move 2 points. So 0, 0, and the point 1, 1. And then we're going to do now the basic transformation, the transformation that is required, which in this case is taking this picture and shifting it down 3 units. Remember, vertical shift only affects the y value. It doesn't touch the x. So my advice to you is first move the points, then draw your picture. Okay? By points, I mean the ones that you decide to use as your basic points. At least have 2 points. Okay? So for example, this point, where does it go? The point 0, 0, where does it go?
0, -3.
0, -3. So it goes down 3 units, so it will be down here. And this point, 1, 1, where does it go? 1, -2. Okay, and then you sketch. So this point went here, so I know that now you draw exactly the same picture that you had before, but shift it down 3 units. So you're gonna have a picture like this. Now, as you know, eventually this is gonna keep going up, and eventually it's gonna go to the x-axis. So there will be an x-intercept. Let's find it, and maybe we redraw the picture if it's, if we can fit it in here. For example, if the x-intercept happens to be 1,000, I'm not gonna redraw the picture because I'm not gonna show 1,000 in this. Okay? I will just say somewhere in here x-intercept is 1,000, and then move on. Okay? We already see the y-intercept is -3, so it's already part of the picture. But as you know, there is an x-intercept that we need to take care of. So let's find it. How do we find the x-intercept? How do we find it? Make y equals to 0. In other words, we need to solve for f of x, square root of x minus 3 equals 0. So what's the solution here? What is it? So x is 9. I will. Okay, so I'm probably. I mean, you could at this point you could just tell me this and then that's it. Or if you want, then you can go here and somehow tell me what is 9. So I guess I'm just gonna draw this. Let's keep going, and then say over here we have 9. And then move on with my life. Okay, even though it should be nicely, but I think I can do better. The problem is that it went down there too much. Something like that. That's better. Okay, question. So now this is a complete picture. Okay, this is a complete picture. This is what we're looking for. Any questions? Yes?
When writing the domain, is 9 the endpoint, or does it continue to go?
So what's the domain of this function?
Yeah, is 9 the endpoint, or does it
No.
go past
You see how
Yes, so
it continues. So domain here is from 0 to infinity. Yeah. So what's the range for this function? -3 to infinity. So when you do a vertical shift, you don't touch the domain because you don't touch the x. So you're touching the y, so what you affect is the range of the function. Okay? Vertical shift affects range. All right? Any questions? Okay, so try this on your own. So how about the absolute value one? So shift it up 1 unit. And remember, you need to show points, okay? If you, for example, if you do this, oh, okay, I know it's something like this. Well, you need to show me the points. Otherwise, I don't know what function it is. Is this +1? Is this +10? I don't know, okay? So, what's the parent function here? So, absolute value of x. And then, what will be the next step? So then we do +1, right? So what's happening from 1 to 2? So we're going to be going up 1 unit. Everybody understand this? Okay, so let's begin. So what's the basic graph? How does it look like? It's a V shape. So we have something like this. X and Y. And then here I'm going to use 0, 0, 1, 1, and -1, 1. Those would be my 3. You need to have at least, so you have this guy, this is an important point, right? The one that has, that little vertex down there. Then at least 1 point to the right part of the picture and 1 point to the left part of the picture, okay? So you have a picture that covers both sides of the y-axis, you need to have at least 3 points, okay? And you're drawing things like this. Or at least 2, but in this case, if you have a y-intercept, you need to start with that one. Okay, anyways, so now all we need to do is, what are we doing to this picture? We're shifting it up 1 unit. So again, is we just keep the same shape. So let's move our points first, and then we draw the shape. So let's see. This point, 0, 0, where does it go? 0, 1, goes right here. 1, 1, where does it go? 1, 2. And -1, 1, where does it go? want to. The moment that you do this, then we're ready to go. Questions? Do you understand this? And in this case, do we need to find any x-intercept? We don't have to find any x-intercept. And the y-intercept is already there. So this is, as good as it gets. That's it. Now, if we would have done, for example, -5, that would mean putting this picture down 5 units. Then notice that there will be 2 x-intercepts that will be created, right? And we need to find them. In that case, we solve the little absolute value equation, right? Okay. Questions about moving graph up and down? All right, so now let's talk about the other transformation. How about right or left? Okay, so let's do the same thing. Let's start with a little example. And then let's try to figure out what's going on there. So let us graph the function x squared again. Graph the function x squared, but this time let's shift it to the right 2 units. Shift it to the right 2 units. And then again, same question. What is the formula of the new function? So what's the formula of the new function? All right, so we know how a square looks like, so we can draw it. X and y, let me do a longer x. So I'm gonna have my points, so 0, 0, 1, 1, and then 2, 4, 1, 2, 3, 2, 3, 4. And then each of these guys, they have their partner on the other side. All right, so we have our x squared function. So this is f of x equal x squared. And then this time what we want to do is we want to grab this picture and shift it to the right 2 units. In other words, we're not moving this vertically, so the y values are not affected. So what we're doing is we are affecting the x values. You understand this? Y is not being affected, only the x. Before it was the y, not the x. This time it's the other way around. So what will be the new location of this point? The point 0, 0. Where does it go? What's the new location of that point?
2, 0.
So it goes right here, right? This guy goes here. Then this point, 1, 1, where does it go?
3, 1.
So it will go all the way up to 3. Notice how the y stays the same, okay? And then this point, negative 1, 1, where does it go? 1, 1. So right here. And then we're gonna have, so let's see, we have two more points. So this one, where does it go? 2, 4. Where does it go? 4, 4. And then this one over here, negative 2, 4. Where does it go? 0, 4. This one came here. And now we sketch. It's actually the same shape because all we're doing is taking that picture and moving it to the right 2 units. So we took this one and shifted it to the right 2 units. So this produces a new function. Let's call it g of x. All right, so now our job, first of all, questions about what I just did. Notice that the y, the points, they never went up or down. They stay at the same y level. What I'm changing is the x. In this case, we're moving it to the right 2 units. Okay? All right, so what would be a reasonable formula for g? Let's try to see if we can figure this out. Okay, yes?
Wouldn't it be like parentheses, x to the square minus 2 and plus parentheses?
Why minus 2?
Because it's the opposite.
Why?
Because that's how it is. I don't know.
Come on, what do you mean that's how it is? That's what we try to do, understand why it is like that. I could just tell you the rule and then that's it. Why did you forget one day? You're not gonna say, that's how it is. But remember, there is a reason for all these things that we're doing, right? So I guess, why is it x minus 2 squared? Let's see, who can justify that to me? Let's see, if you already know these things, you are expecting already these to be this, right? Why?
Because it's a 0.
What do you mean by that?
I'm not sure, but you'd have to add it. And then you'd have to add it to get the 0. Oh. Sorry, I can't explain it.
Okay, let's see. Yes?
So like, if you think about it, if you plug in 2, it has to return 0. So, and 3 has to return 1, 4 has to return 4.
Okay. What do you want to return?
Like the y value.
Very good. Very good. You see? So remember, we are not touching the y values. We are only messing around with the x's, right? But we want, we are changing the x, but we want the y's to remain the same. So, for example, in this new function, what does it take to be able to obtain 0? You have to plug in 2. But remember, the main function here is a square. If you want to get 0, you were expecting to get a 0 here. But this time, if you want a 0, you need to put here a 2. Do you understand this? So if you want to get down here, you have to plug in a 2. For example, if you want to go up to 1, what does it take now? What do you need to plug in? You need to plug in a 3, right? So, and if you look at the picture, then it went up to 1, given a 3, but then the thing is that you want to actually recover the behavior of the x squared, so that means you have to return to this previous point, and you can do that by doing minus 2. So minus 2, and so on. But again, typically, remember, typically you don't have the picture. What you have is this, and then, the moral of the story is that if you want to get the same behavior as the x squared, it's that you need to, go 2 units ahead, because if you want to get the behavior of 0 squared, you have to plug in 2 as 2, not 0. If you want to get the behavior of 1 squared, you have to plug in 3, not 1. So that's why when you see this, it means, okay, I need to go ahead 2 units, so to the right 2 units. If you want to look at it backwards from the picture to the formula, then it's what your classmate was saying. Well, I want to return to this point. So how do I return to this point to obtain my 0? I subtract 2. How do I return to this point to obtain 1? I subtract 2. Okay? This is a little bit dangerous because, as your classmate said, the operation here is the opposite of what you may think. For example, when we go up and down, typically when you see plus, we're talking about up and down. Plus make you think about up and negative down. When we talk about right and left, the natural thing, if you take somebody random on the street that is not used to talk about these things, if you say, what would you say plus is? Is it right or is it left? What do you think they're going to say? Typically, they're going to say right. They're not going to tell you that plus is left. Okay? Because you add to get bigger stuff and you subtract to get smaller stuff. You understand this? You have to be careful because here is the opposite of what you typically would like to think. So when you do minus something in the x, it makes you go right. If you do plus something in the x, it makes you go left. So in the y direction is intuitive, in the x direction is counterintuitive. Like the first thing that comes to your mind. Okay? So as your plan says, it's the opposite. Okay? So if you want to go right, put a minus. If you want to go left, put a plus. So if we wanted to shift this to the left 2 units, this would have been x plus 2. Does that make sense? Okay, good. Let's see. How would you write this in terms of f? How would you write this in terms of f? For example, right here, this one, we can write it in terms of f by just saying that this is f of x plus 2, right? That's what it is. So we wrote g using f. So how can you write this g over here using f? Yes.
It's f of, and then in parentheses, x plus 2.
Look again.
Minus.
Okay. So good. So this is f of x minus 2. Okay? Because all we're doing is f is the x squared function, and then we are replacing x by x minus 2. Do you understand this? So now when I write the general definition, then of course I need to write it in this form. So notice the difference. If you want to go up or down, what you do is you add or subtract outside the function, outside the whole thing, the entire formula. Now, if you want to go left or right, what you do is you plug in into the function. X minus something to go right, x plus something to go left. Do you understand the difference? Okay. So, let me write down the statement. So this is horizontal shifts. So this is the second rule of the game, if you want. The first rule is that you're allowed to add or subtract numbers to the whole function. Here, the second rule is you're allowed to replace x by x plus something or x minus something. Okay? So let's see, be a positive number. Then the first one is y equals f of x minus c. Is a horizontal shift. It's a horizontal shift to the right of f by c units. And then if you want to go left instead, then what you do is you plug in x plus c. In other words, remember, plugging in means replacing x by whatever you're plugging in. So if you replace x by x plus c, what happens is you're going to go left. So this is a horizontal shift to the left of the function f by c units. Questions? All right, so let's do an example. So for example, let's do a sketch. Then let's do f of x equals square root of x plus 3. And then let's do f of x equals x minus 2 cubed minus 4. Okay, so here we have two functions, and then our job is to sketch the graph of these functions. Again, the same idea as before. The first thing that you need to do is recognize what the parent function is, and then figure out what are the transformations that are taking place. Okay? So let's see. Let's do the first one. So we have f of x equals square root of x plus 3. What's the parent function here? So as a square root function. So f is already has a name. It's a square root of x plus 3. So instead of calling it x, let's just call it y. Just remember, now f is this function for us. Okay? So just use another letter or just use y. So the parent function is y equals square root. Okay? How many transformations are we doing to the parent function? One transformation. And algebraically, what is it? Algebraically. That's geometrical. Algebraically, what is it that we're doing? We are replacing x by x plus 3, right? Instead of an x, what we're doing is we are replacing it by x plus 3. And that is a valid operation in this little game that we're playing. Okay? Remember, we have two rules so far. You're allowed to add or subtract a number to the entire formula, but also you're allowed to replace the x by x plus something or x minus something. That's the second rule that we have introduced. Okay? That's the one that is happening here. Now, when you do this, what effect does it have on the graph? What's the geometric consequence of this? So this is moving whatever this picture is to the left 3 units, right? So from 1 to 2, what's happening is that we're going left 3 units. Okay? The moment that you have this written down, then all you have to do is begin with the basic picture and then do do the corresponding transformation. All right, so let's do it. So again, this is one of our basic functions, which we know how they look. This is the square root function. So begin with this picture, 0, 0, then 1, 1. And now we need to move this to the left 3 units. All right, so X and Y. So remember, this is a horizontal shift, therefore the Y values are not as affected. So let's move the points first. Where does this point go? 0, 0, where does it go? So negative 3, 0, right? Think about it.
Oh.
1, 2, 3. They're going left, right? So negative 3, 0. And where does this guy go? 1, 1. So remember, the Y stays the same, so the Y is still 1, but then you need to go 3 units. So 1, 2, 3. That's a negative 2. Okay? So negative 2, 1, and then you sketch. So let's see. Something like this. Okay? Now, this time, the x-intercept is already part of the picture. Okay? But we have the y-intercept, so let's find it. So what is the y-intercept here? Come tell me who is this guy? How do you find y-intercept of a function? Remember, this graph corresponds to this formula. How do you find the y-intercept of a function? So when x is 0, what is y? Square root of 3. What's your y-intercept? Square root of 3. Do you understand this? Now the picture is complete. Remember, if you don't tell me what this is, then this is an important point you need to tell me. All right. Questions? Let's see. Before, when we went up or down, so when we did a vertical shift, the range was affected, not the domain. This time, what's happening to the domain? For example, what's the domain of the parent function? What's the domain of this guy? 0 to infinity, right? What's the domain of this new function? Negative 3 to infinity, so the domain was affected. Okay? The range was not. Here the range is from 0 to infinity, here the range is still from 0 to infinity. Okay? So vertical shift affects range, horizontal shift, they affect domain. Okay? Sometimes. If the domain or range is negative infinity to positive infinity, then if you do a shift, that's not going to affect anything. All right. Questions? Okay. So let's do the second one. So the second one was f of x equals x minus 2 cubed minus 4. So let's do this one, then we take a little break. All right. So what's the parent function here? The x cubed function. Remember, when I ask you what's the parent function is, what does this function looks like formula-wise when you think about the 8 basic functions that we listed before. The only one that should come to your mind is x cubed because of the cube here. Okay? There's no radical, there's no square, there's no 1 over something here. So you should think about the x cubed. All right, so y equals x cubed. So next, the question is, how many transformations are we doing to this function? How many transformations are happening here? So there are 2 transformations here. What are they?
2 to the, you shift 2 to the right and 4 down.
Very good. So for example, now that we know how to go up and down, right and left, we can now start moving diagonally as well, right? Because when you move diagonally, that's what it means, to go right or left, or up or down. Okay, it's a combination of the 2 movements. Now, here it doesn't really matter which one you do first. Here you could decide to go down and then right, or go right and then down. It doesn't matter. But when there are more transformations in the mix, it's actually better if you first do anything that you need to do that happens on the x-axis before you start moving away from the x-axis. Because, for example, when you are on the x-axis, doing reflections is easier. When you are away from the x-axis, doing reflections could be a little bit complicated. Okay? So in particular, what I recommend is when you have a situation like this transformation, this one that's here, that's either up or down, you should do it last. Anyways, if you're going to evaluate this function, this is the last thing that you will do, right? You put something here, then you do -2, you cube it, and then the last thing that you do is a -4. So my advice is leave this guy to the end. So in this case, even though it doesn't matter for this particular problem, I'm gonna go right and then I'm gonna go down, okay? And it's good practice to just do whatever you need to do in this part before you get to this one. All right, so this one will take 2 steps. So let's see. Remember, 1 step at a time. So what we're gonna do is now now the game is a little bit more interesting than we've done before. The idea is to slowly build from this function. We want to build this one, this formula, and you can only use the rules of the game. What are the rules of the game that we have learned so far? You can add or subtract numbers to the whole formula. You can replace x by x minus something or x plus something. That's all you can do. Okay, up to now. So, what can we do here to build our way towards that formula? What can we do?
Replace x with x minus 2.
We replace x with x minus 2. So that means that we're going to obtain something like this, right? The moment that you do that, that immediately tells you what's happening from 1 to 2. So what information is happening? So that means that we're going right 2 units. Yes? Okay. So now, what can we do to this formula, the 1 step 2, to get closer or to maybe get already to what we need? What can we do to obtain our function? Subtract 4, and this is a valid rule. Okay, we're allowed to do that. So then you can take that one, and then we can do -4 too. Okay. All right, good. And then that means what's happening from 2 to 3?
Shifting for this down.
So we're going down 4 units. Do you understand this? So the moment that you have this written down, you already have a plan. Okay? It's just a matter now of starting with the basic function and then carrying out the desired transformations one at a time. All right. So again, now you go. You remember how this looks. X cubed. This is the shape. And remember 3 points. So 0, 0, then 1, 1, and then -1, -1. So we're going to be moving these points as we go along. All right, so we're going to go down, we're going to go right 2 units. So let's do the next picture. So where does the point 0, 0 goes? Where does it go? 2, 0. So 1, 2. Then -1, -1. Remember, the y stays the same. So let's go to the right 2 units. So it's going to go to 1. And then 1, 1 is going to go to 3, 1. And then we draw exactly the same shape. Okay? So if you want, you can go ahead and figure out the y-intercept in this case. Let's see, what's the y-intercept in this case? What's the y-intercept for this picture, for number 2?
12.
-8. You plug in x equals 0 and you get -2 cubed, right? Which is -8. Do you understand what I'm saying? Because I get the feeling that you know this, but then I ask you questions and everybody's quiet. You don't answer. So do you know this or not? Okay. So it's -8, okay? All right, I'm not gonna write it there, but it's -8. Because then I have to go down too much. All right, and then lastly, so if if you want, make a note here. Our y-intercept is 0, -8. And then lastly, we arrive to the desired picture, which now we have to go down 4 units. So let me put my y-axis over here. So x and y. Okay, so let's see. So this time we need to go down 4 units. So this point that is at 2, 0 is going to go down 4 units. So now it's going to be down at -4, right? So 2, -4. So 1, 2. I also need to have 3. So let's have them here. 1, 2, 3, 4. So it goes down here. Then the point 3, 1 is going to go down to 3, -3. And then the point 1, -1 is going to go down to 1, -5. Okay, and then we have our function. It's at the same shape. The inflection point happens right there at 2, -4. You know, the inflection point is when we change concavity. This is concave down, and then at this point it changes and becomes concave up. Okay, so a little turn happens here, and then shoots up. Now here we're gonna have both x and y intercepts, so we need to say something about those. Okay, so the y-intercept. Let's see. I'm not gonna draw it, but what is it? -12. So I'm just gonna put here y-intercept is 0, -12. Now the x-intercept, we can draw it. So let's find it. How do we find x-intercept? So we set the function equal to 0. Remember, that picture corresponds to the formula. So we set it equal to 0. So it will be x minus 2 cubed is equal to 4. So x minus 2 is the cube root of 4. So this is 1 point something. And then this is 2 plus the cube root of 4. So that's going to be 3 point something. Okay? So it's slightly to the right of 3. But it's less than 4. Okay? Because cube root of 8 is what's going to give you 2. So to get 4 here, you have to have 2 plus 2. So you need to have an 8 in here. Okay? So it's between 3 and 4. This is 1 point something. Cube root of 4 is 1 point something. So that's 3 point something. That's fine. So that's this guy. And then, you know, we just say that this one is 2 plus cube root of 4. And now this is a complete picture. You know, this graph has all the necessary data. All right. Questions? Yes.
Why did you go to 13? Because it's the y-intercept -12, so what did you do on the y-axis?
What was the y-intercept before? -8. So that means it's a point down here. There's a -8. We're going down 4 units. What will be that point? -12.
Yeah. No, but like on the x-axis, it's not -8, it's 13.
No. Okay, this is like, you know, these little lines.
Oh.
Okay. Yeah, I understand that was confusing. So let me. Yeah, those are, you know, these little lines here. So let me put the 3, I guess, on top. All right. Good. Any questions? No? Okay.